In this video, I'm going to go over probability for chapter 11.5. For this particular section, what we're going to go ahead and discuss is or and problems. So for the first problem, when you read the problem and you see the word or in the probability, this is the formula we're going to be using. The probability of A plus the probability of B minus the probability of both together. So this is usually designated to be the first probability, the second probability, and both if they occur at the same time. So for example, each of the numbers 1 through 10 is written in a separate sheet of paper. The 10 pieces of paper are then placed into a hat, and one piece is randomly selected. Determine the probability that the piece of paper contains an even number or, so here's the or that we're looking for. The key word for us or is now we know we're going to use this formula here. A number greater than 6. So whatever comes before the or is considered to be my probability, my first probability. So determine the number that contains the even number. So in this lesson here, how many even numbers do we see? 1, 2, 3, 4, 5. So it'll be 5 out of 10. And then we need to find out the probability of number greater than 6. So 1, 2, 3, 4. So this would be 4 out of 10. So 5 out of 10 plus 4 out of 10, and then 2 out of 10. This is the tricky one. So for the end, we need to figure out it has to occur at the same time. Your answer must be even, and your answer also must be greater than 6. Both of them has to be. So again, how many evens are there? 1, 2, 3, 4, 5. But how many of those out of those 5 we just listed, how many are actually greater than 6? Just the 8 and just the 10. So that's what we get 2 over 10. So remember, the 10 comes from the total number. The numerator comes from what we're talking about. There are 5 even numbers. There are 4 numbers greater than 6. And there are only 2 that are even and greater than 6. That's just 8 and 10. So we place it in the formula, add the first 2 together, subtract the last, and we get 7 out of 10 is going to be the probability of selecting an even number or a number greater than 6. Here's another example. Same numbers, 1 through 10. Same if we select one piece of paper. So determine the probability if it contains a number less than 5 or, so then we use the formula again, a number greater than 8. So a number less than 5 consists of 4 over 10. So that's going to be 1, 2, 3, 4. Those are my numbers that's less than 5. Now we need to know the numbers that are greater than 8. Well, it has to be only 9 and 10. So that's why my 2 was over 10. However, what is the probability of the number being less than 5 and it also has to be greater than 8? So this here doesn't make sense because how can a number be less than 5 and that same number that we listed also be greater than 8? This is where we put 0. So basically when this does not occur, we can put 0 at the end, add the two numbers, and we get 3/5 as the possibility of us selecting a number less than 5 and greater than 8. That 0 that we just discussed, this is called mutually exclusive, meaning that it cannot happen or occur simultaneously. So that's why we put the 0 there, and we just go by performing the two problems, just add them together because we don't need the 0 at the end. Now we're going to go into and now. So with and, we're just multiplying together. So or, we're taking both of these and adding it and then subtracting. Now for and word problems, we're going to be multiplying. So here, 2 cards are selected with replacement from a deck of cards. Determine the probability that 2 spades will be selected. So here, probability A is the first spade being collected, and then probability 2 be the second spade being collected. So remember, in our suits, when you have your cards out, there are 52 cards in the deck. In every suit, we have spades, clubs, hearts, and diamonds. There are 13 suits. So the probability of us selecting a spade is 13. And remember, we're doing this with replacements. That means we put that card that we selected, that spade, back into the deck. So now we have another full deck that we're talking about. So 13 out of 52 times, when we click again, it'll be 13 out of 52 again. Reduce these, 1/4, we get 1/6. So basically, again, replacement means we're starting over from scratch from the beginning, like nothing ever happened. So like I said, we select this one, 13 of here, and then we put it back, and then we select it from here. We have a 13 out of chance again because we put that spade back. There are 13 spades in both times we selected as a probability. For this experiment now, we're going to talk about without replacement. That means when we take it out, we're not putting it back in. So same problem. Remember, the first time we do it, we're going to have 13 spades out of the 52 deck. But now, since I'm not replacing that spade back in the deck, guess what? Instead of 52, there's only 51 cards. And then because that spade is not replaced into the deck, we only have 12 now. So the second time we do it, it's going to be 12 out of 51. So reduce, multiply together, we get 1/7 to be the answer. So looking at these problems here, just to kind of know the difference between dependent and independent, is the question is asked, 100 people attended a charity benefit to raise money for cancer research. 3 people in attendance were selected at random without replacement. And each of them will be awarded a door prize. Are the events of selecting the 3 people who will be awarded the door prize independent or dependent events? Now remember, because we're not without replacement, that means we're not going to replace it back. So this is considered to be dependent. Independent variables occur when any of the events have no effect on the other one. So if I actually put it back, that will consider to be a with replacement, that considered to be an independent. So basically, replacement events will always be independent events. Dependent events will be without replacement. So I'm going to go over a couple of examples in section 5. So here we have a problem. Make this a tad bit bigger. So here we're problem here. A single 6-sided die, remember we're working with a die, is rolled. Find the probability of rolling an odd number, or, so here's my or formula, a number less than 2. So what is the first probability that we're talking about? So probability A is what the probability of rolling an odd number. So if you look on the die, remember there are 6 faces on the die. And all those 6 faces, in order for it to be odd, there should be 3 odd numbers. The 1, the 3, and the 5. And how many total is it on the die? Remember, it's 6 sides, so it's going to be a total of 6. That's probability 1, plus the probability of the second part, which is going to be what is the probability of its number less than 2. So on the die, we have 1, 2, 3, 4, 5, 6. The only 2 numbers that's less than 2, I'm sorry, only 1 number is less than 2. It's just this one here. So there's actually 1 out of 6 for probability. Minus, now we got to do minus both of them together. So this is the P and the B. So probability of A and B. So both of them together, now remember, it has to consist of an odd number and it must be less than 2. So all these numbers here for the first one is 1, 3, and I'll highlight it. 1, 3, and 5 are my odd ones, but the only one that's also less than, out of these 3 I selected in yellow, the only one that's less than 2 is the one we circled here. So there's only 1 out of the 6 possibilities. And here's my formula. So once we put this in our calculator, our answer should be 1/2. So for this one here, we have a board game with 20 cards. So there's 5 by 4, that makes 20. 2 cards are selected at random from this deck. Calculate the probability of both cards selected have a red bird, both with and without replacement. So we're going to do it with replacement first, and then we're going to do without replacement next. So let's start with the with replacement. So we're going to calculate the probability that we have a red bird. So how many red birds are here? 1, 2, 3. Out of what? 20. Times, and this one here, remember we're doing with replacement first. We're going to work on this one first. If we replace it, our second probability, so we actually chose a bird, but we're going to put it back in because we're going to replace it. So we still have 3 birds because we replaced it, and we still have 20 cards. So if we multiply that together, or you can just times it by 2 since it's 2 of them, we get 3 out of 10. So this is with replacement. Now we're going to do without replacement. So the probability for the first trial is still going to be the same. There's still 3 out of 20. However, the second one, since we're not replacing that red bird that we selected, we get rid of it. And now we look at it, we only have 2 red birds left. And out of the whole deck, there's only 19. So we take both of those and multiply together. And we get 3 over 190. And this is without replacement. So let's move over to a similar one. So same setup for this one here, but this time we're going to be finding the probability of a yellow bird, and then on the second time we're going to find the red bird. So let's talk about the first probability. How many yellow birds do we see in this problem? So 1, 2 yellow birds. So we have 2 over the total of 20 cards altogether. Times, now this time here we're going to be doing with replacement. So for here we're going to put that yellow bird that we selected back in the deck. So we still have a full deck of 20. However, this time we're looking for the second one to be a red bird. So how many red birds do we see? 1, 2, 3. So for this one here, we multiply them together in our calculators. This one should be 2. And we get 3 over 200. So this is with. Now we're going to do it without replacing it. Same 2 birds that we're talking about, we're going to do without replacement. So the first selection is, again, we're looking for yellow birds. So we still have 2 yellow birds. First trial. This time I actually found a yellow bird. I'm going to pull out, but I'm not going to put it back in. So I'm doing without replacing it back into the deck. So we already know if I already selected one of these birds, there's only 19 in the total. But what am I looking for now? I'm looking for red birds now. So 1, 2, 3. So there should be 3 red birds. So we have a 3 out of 19 chance to try to pull a red bird out. So we multiply both of those together. Change this to a 19. Math, enter, and we get 3 out of 190. And this is without replacing. So you can see with replacement, the total actually stays the same. Without replacement, depending on how many times you actually select, it drops down every time you do a trial for the total. Last problem we're going to go over is we're going to determine the probability that you get a green on the outer wheel, and so for n, remember the formula. It's just when we multiply. A yellow for the inner wheel. So let's start with the green. Here's the outer wheel. And how many green do we see? We see 2. But how many? So we have a 2 out of what chance to get a green? Let's look at the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Times. Now let's look at the inner wheel for a yellow. So here's one yellow. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So it's 1 out of 8 chance that we get a yellow for the inner wheel. So we do the math. So you have 2 out of 12 times 1/8. And we get 1 out of 48. All right, so this concludes 11.5. Let me know if you have any questions.